So our last topic, our last unit, is probability and statistics. For this unit, I'll give you video guided notes that you can use as you choose. You can do them the same way we do them on the video, or you can pick and choose what you need based on what you remember from probability in previous years. So, the probability is the measurement of chance, the likelihood of something happening. We have a very specific definition for probability that you should remember from Algebra 1. It states, in an experiment with a set S of equally likely outcomes, the probability of an event E is the probability of that event is equal to the number of outcomes in E over the total number of outcomes. So for example, if we had a basic dice problem, if I asked you what's the probability of rolling a die and it landing with a 2 up, the number of outcomes in E is 1. There's 1 2 on a die, and the total number of outcomes is 6. There are 6 sides on a die. So that's what that basic probability definition means. Let's do an example. Scientists are trying to determine how likely it is that a mouse will correctly maneuver through a simple maze to obtain food. The mouse must make 3 turns, either left or right, to get through the maze, but will only get cheese at the end if it makes 2 lefts and a right in any order. So part A is asking you to make a tree diagram. Again, drawing a tree diagram helps you organize all your information, and what you do is you list all the possible outcomes in each trial. So for this example, the mouse is either going to be able to go left or right in 3 turns. So in his first turn, he will go left or right, so you show that. And then regardless of what happened in his first turn, he'll go either left or right again. So if he went left on the first turn, he can go left or right on the second turn. If he went right on the first turn, he can go left or right on the second turn. And the same thing happens on his third turn. It doesn't matter what happened in the first 2 turns. In all those cases, he could go either left or right that last time on the third turn. So you list all of those possible outcomes in your tree. And again, the tree helps you organize so that you don't forget any of the possibilities. Part B says, summarize these routes by listing the sample space in terms of ordered triples. So they want you to use parentheses to show the order, and all you're going to do is read the branches in your tree. So the first possibility was left, left, left. And so you list left, left, left. The second possibility was left, left, right. So you list that. And you continue down your tree, left, right, left, left, right, right. You're out of lefts, so now we can start with our right turns first. Right, left, left, right, left, right, 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 left, or finally, right, right, right. So again, listing those sample spaces from your tree diagram, make sure that you don't forget anything. Some people can do this in their head, most of us cannot. Part C says, list the routes from Part B that would result in the mouse getting cheese. So you need to go back and reread the problem. When we read the last sentence, we are told that the mouse will only get cheese at the end if it makes 2 lefts and a right in any order. So we're going to look for our possibilities where the mouse gets 2 lefts and a right in any order. So again, you can go through your tree, or it's probably easier to just go through your list. So there's a left, left, right, 2 lefts and a right. Next is a left, right, left. There's 2 lefts and a right. And if you go to your next list, there's a right, left, left. There's 2 lefts and a right. Again, the order does not matter. And then finally, for Part D, we're asked what is the probability that a mouse will get cheese if all the possible routes are equally likely? Well, there were 3 ways that the mouse could go 2 lefts and a right in any order. So that is our number of outcomes in the event, 1, 2, 3. And there are 8 total possible outcomes. There are 8 total ordered triples that we listed. So that's our denominator. The probability that a mouse will get cheese, if all possible routes are equally likely, then is 3/8. Let's do another example. In exercise number 2, Carlos is trying to grab 2 dimes out of his pocket, which contains the 2 dimes and a penny. Assuming that Carlos randomly grabs 2 coins without replacement, what is the probability that he got the 2 dimes? Draw a tree diagram or list a sample space to justify your answer. Again, I prefer both, a tree diagram and the sample space. So let's think about what's going to happen. He starts with 2 dimes and a penny. So let's start with a tree that shows me 2 dimes. We'll say dime 1, dime 2, and a penny. Call it P. Now, this problem says that he grabs 2 coins without replacement. So, if he grabbed that first dime, he can't grab it again. It's out of his pocket. So for my second dime, or my second coin that he pulls, it could be dime number 2 or the penny. If he pulled dime 2 first, he can't pull that again because it's already out of his pocket. So he could have pulled dime number 1 or the penny. And if he pulled the penny first, he can't pull it again. It's already out of his pocket. So now his choices are dime 1 or dime 2. Now from the tree diagram, I can list my sample space. I have dime 1, dime 2, dime 1, penny, reading the tree. I have dime 2, dime 1. I have dime 2, penny. And then I have penny, dime 1, and penny, dime 2. So here I've drawn a tree diagram and listed the sample space. I know it said or, but I prefer both. And now let's reread the question. What's the probability that he got the 2 dimes? So we look at our possible outcomes of 2 dimes. Here I have dime 1, dime 2. Here I have dime 2, dime 1. So there are 2 cases out of 1, 2, 3, 4, 5, 6 possible outcomes of him getting 2 dimes from his pocket. In probability, you do not have to reduce. Often we won't because it really shows the meaning of the probability. If you choose, you can say 1/3.